Students, today we will solve the numericals based on potentiometer. Like the first question we are taking, in a potentiometer arrangement, a cell of EMF 1.25 volt gives a balance point at 35 centimeter and another cell gives the null point at 63 centimeter. Then find the EMF of second cell. So you know that whenever we are having two primary cells, from the formula of comparison of EMF of two primary cells, we have the formula E1 upon E2 is L1 upon L2. So on substituting the values in this formula, we get 1.25 upon E2 is 35 upon 63. So now take E2 on one side and remaining terms on the other side, and after the calculations we get EMF of second cell is 2.25 volt. Normally this sort of question can be there in 1 mark. Now this question, this is a very lengthy question wise you can say, and this was asked in 5 marks. Like in this question, a diagram of potentiometer is given, and here what we have taken, this is the your driver cell whose EMF is 2 volt and internal resistance is 0.4 ohm. Then a primary cell is taken of EMF 1.02 volt and the length of null point was 67.3 centimeter. And a resistance of 600 kilo ohm is connected in series with the primary cell, which is shorted near the null point. Now the question is saying, in this setup, what if we have to calculate if we replace it by another cell for which the null point is obtained at 82.3 centimeter. So in that case, what is the value of the EMF of second cell? Second, what is the purpose of this high resistance of 600 kilo ohm? Third, is the value of null point affected by this value of 600 kilo ohm? Next, is the value of null point affected by the value of this internal resistance of the driver cell? And next, if we are having a very small EMF, means another cell whose EMF is very small, say of the order of millivolt, then can we use this method for that primary cell? And last, if we are having a driver cell of 1 volt, then will this method work? So now you know for the first part it is easy directly by comparison of EMF, E1 upon E2 is L1 upon L2. So in that case, if we substitute the values, so we get EMF of that primary cell, means the second one, will be 1.25 volt. Now if you see this circuit, so here, so we are having it near the primary cell. So we are using this resistance so that if we are not having the null point, means we are away from the null point. In that case, if say somehow the polarity is wrong, or if any other, you can say this value, whatever we are having the imaginary cell which is formed, the EMF of that cell will be high also. So it may happen that the two currents are there in the same direction. So we want to save the primary cell from damage and the galvanometer also from damage. So that's why we connect this cell when we are away from the primary cell as a safety measure. And when we are about to get the null point, then we switch off this, you can say this key is there, we insert that key because that resistance is very low, and you know in parallel the current will follow the low resistance path. The maximum current will go through this. So this 600 kilo ohm will not be there in the circuit, and we say this resistance is shorted near the null point. So basically this resistance is used for saving our primary cell and the galvanometers from heavy currents. Next, this value you know at the null point this primary cell behaves as if it is an open circuit. So this value of 600 kilo ohm will not affect the value of null point. Now you know this internal resistance. So you know when we calculate the EMF of this primary cell we take, when we calculate the potential difference across AB, then that is given by EMF of primary cell minus voltage drop across any resistance which is connected in series with the driver cell. It can be any external resistance or maybe the internal resistance. So we say if the value of R changes, means internal resistance, then the value of potential gradient will change, and hence accordingly the value of null point will change. Next, if the driver cell is having the EMF 1 volt, so you know the EMF of driver cell should always be more than the EMF of primary cell. So we will get one-sided deflection and this circuit will not work. And last part, if the value is of the order of millivolt, then you know for that case the value of null point will be very small. So we can say very close to 0 mark of the scale. So in that case the percentage error will be very high. So in order to reduce the percentage error, we have to connect a very high resistance in series with the driver cell, so that the value of K becomes very small and accordingly the value of length increases. Now next question. Say here we have to calculate the internal resistance of a primary cell using a potentiometer. So in that case, the question is saying that driver cell is having the EMF 2 volt. The EMF of primary cell is 1.5 volt. And when we use the primary cell in the open circuit, then the value of null point is 76.3 centimeter. And when we use our external resistance of 9.5 ohm in parallel with the primary cell, then the null point is obtained at 64.8 centimeter. So what will be the value of internal resistance of the primary cell? So you know, if we have done this derivation, internal resistance of primary cell is given by L1 upon L2 minus 1 into capital R, where L1 is length of null point in open circuit, L2 is length of null point when we connect a value of resistance R in parallel, and capital R is the value of external resistance. So on substituting the values, we get 76.3 upon 64.8 overall minus 1 into 9.5. So on solving, we get approximately 1.7 ohm. Now next question is saying if we are having a driver cell of 6 volt. In series with that, we are having a resistance of 10 ohm. And this potentiometer wire AB we have taken. And a primary cell is connected in parallel with this potentiometer. Now the question is saying that resistance of, you can say in this case, the length of potentiometer wire is 2 meter or 200 centimeter and its resistance is 20 ohm. Then we have to calculate the value of null point for the primary cell of EMF 2.4 volt. Now you know that when we have to calculate the length of null point, then we say EMF of primary cell is given by K into L. So here you know that value of K is, you can say two methods are there. Number one, resistance per unit length into current flowing through that, and second thing is given by E upon K, E upon L in this case. So we are having the value of current we are calculating first. So in primary circuit, the current will be net EMF upon net resistance. So in this case, if you see resistance of AB and this 10 ohm are there in series, so we have 6 upon 10 plus 20 means 6 upon 30 or 0.2 ampere. Now value of K is I into small r, where small r is resistance per unit length of potentiometer wire. So we have I into resistance of AB upon length of AB. So on solving, we get the value of K as 0.02 volt per centimeter. So if we substitute the value in the primary cells formula like E dash is K into L, so we get EMF of primary cell is given 2.4, K is 0.02 and L we have to calculate. So on solving, we get L is 120 centimeter. And last question for the day, driver cell of EMF E is used in the circuit where a resistance 10 ohm is connected in series with the potentiometer wire. The resistance of potentiometer wire is 5 ohm and the length is 2 meter. So we have to calculate the value of E so that the potential gradient across the wire AB is 2 volt per meter. In this case, again you know we are getting K by 2 formula. One is I into resistance of AB and second is I is E upon L. So that way we get I is E upon total resistance, the resistance of AB plus external resistance. That means E upon 15. Then K value is given by I into resistance of AB means resistance per unit length of wire AB. That value is I into resistance of AB upon length of AB. So we get value wise, means resistance of AB is 5, length is 2. So we get K is E upon 15 into 5 upon 2 means E upon 6. So we get E upon 6, value is 2 given in the question. So E is 12 volt. That's all for the day, and you can clarify your doubts or any problem or questions in the class group. Thanks and take care.